Today I'm going to be talking about event-driven architectures and how on earth you pick serverless compute for it. Because obviously you've got serverless applications that you're going to be running or non-serverless applications. But I think serverless compute is the best way to do your compute for your event-driven architectures. Now, I know we're here in an audience of people that know a lot about lots of things. But just, what is the point of serverless? Well, the point of serverless is that AWS takes over as much of the stuff as possible, and the big picture is that you can focus on writing code that solves your business problems. But now you're writing code to solve your business problems, and so you need some sort of service to run that code, and that's why we're talking about serverless compute. But serverless has a lot of things at AWS, and even beyond the industry, there are other players and other cloud providers who also provide serverless services. So although we're going to talk about some of our compute services today, please remember that serverless is way bigger than just compute, even though sort of serverless was a bit born when Lambda came out, which is 10 years ago. But if you think some of our foundational services at AWS, like SQS and S3, were born many years before Lambda and are very much serverless services as well. So I sort of sometimes say flippantly that the cloud was actually born serverless because S3 and SQS came out before EC2. So before you could even rent a virtual machine, you could use S3 and SQS, you could use our serverless services before someone probably begrudgingly said, oh, we need virtual machines, okay, and came out with that as well. But of course nowadays it's storage and workflows and analytics and many databases and different integration services and a whole bunch of other serverless services that you can use with AWS and other companies as well. So there are, we're in the world of Gen AI, there are vector databases that are serverless. There are, Memento is coming out with a really cool cache. There is Neon, and there's, other kind of services all across the industry. New revolutions of Kafka, for example, with Confluent and Red Panda, which are all coming out with serverless services as well. So the point of that is that serverless isn't just an AWS thing, but obviously AWS is also heavily investing in building more serverless services. And obviously this runs at ridiculous scale. I mean, Lambda processes, tens of trillions of requests a month. What have I got here? EventBridge, more than 2 trillion events are done. And, ECS tasks, over, 2 billion ECS tasks. And these are probably, rolled. They're going to be more figures than that. So, I mean, serverless at AWS runs at absolutely ridiculously massive scale. And part of the benefit of serverless is also this sort of utilization thing. If you've got a traditional on-premises infrastructure, you've always got to pick a load that you're going to do something, and if your throughputs or something goes above that load, well, you're going to not make your customers unhappy. Now with EC2, sure, you've got auto-scaling, you've got various load balancing things, you can do that, and there's this sort of stepping up thing, but often you can't handle that top peak because you can't just react in time. While with serverless services, generally they're going to scale up as much as possible. Now, there's some ways you want to maybe control that, or you don't want things to scale up, but the point is, generally with serverless services, you've got this the scale that matches your capacity, which is exactly what you need. But fine, that all sounds interesting, but the actual reason you go serverless is this faster time to market. You've got an idea and you want to get it into production as quick as possible. And when you're using a serverless approach, you can get rid of a whole bunch of that EC2 provisioning or clusters or nodes or auto-scaling and all that kind of thing. You just don't have to think about it. And so you can get ideas out to market. Listen to what your customers want, and sort of some people say, take your prototype idea into production really quickly. And that for me is actually the benefit of serverless, is to do things quicker. Sure, sometimes serverless services are going to get complex as your business gets more complex and going to be, create these huge big applications. But if you've got an idea and you can try it out really quickly, that's really powerful. And if your idea doesn't work, well, you try another one. While if you're using a sort of EC2 or non-serverless approach, trying that idea is going to take a long amount of time. So my name is Julian Wood. I'm a developer advocate within the service team at AWS. Eric and I are on the same team. And before I did a lot of the EC2-based stuff as an infrastructure engineer, and luckily I saw the light and I sort of love talking about serverless. But today we're at EDA Day, and we're sort of all talking about events, and we've got producers and consumers and event brokers and message buses and queues and topics and streams and all these kind of things. But today we're talking about events and how we get things from A to B, and particularly in my talk all about compute. And our sort of main service for events is called Amazon EventBridge, and this is just a actual really simple service. Does anybody have an AWS account? Anybody going to hand over? Okay. So you're already using EventBridge. You may not know it because every AWS account comes with a default event bus. And anytime AWS, any infrastructure or change to any service in AWS generates an event, and it's already put on your event bus. Now, luckily, you're not sweating and panicking thinking you're paying for this already with everything that's going on in your account, but EventBridge came out of CloudWatch events, and so anything that's reacting to anywhere in your AWS account is already flowing through your EventBridge account, and that's cool because you can do stuff on that. So if an EC2 instance appears on the network, or someone adds a tag, or does something, you can react to those events. But the thing that made Amazon EventBridge even cooler than CloudWatch events is where you can then run your own custom applications. So you can have another event bus or use a default event bus and generate your own events on that. And then thirdly, you can also connect SaaS partners to EventBridge. And so if you are using Zendesk or PagerDuty, or there are tens of different partner integrations where the events from this partner will just be put on your event bus. You don't have to run a webhook or poll or do any API calls to them. And it's a really efficient way to connect these services, external services, to AWS with your custom events, with your AWS events, all in one place. And pay for the events you process, so it's got that sort of scaling mechanism, not just from the throughput, but also from the costing. And then on the other side, some of the earlier talks today have been talking about step functions. And so EventBridge is many things come in and can go to many targets. Step functions is what you use sort of within a microservice when you need a transaction or something that's a bit more coordinated. For example, you've maybe booking a flight or doing something, some bank transaction, and if the bank transaction for a flight fails, well, you need to reverse that transaction and you need to release the seat, for example, or a loyalty point, or whatever, some kind of different things that are coordinated together, and step functions does this. Is anybody using step functions? Excellent, we've got some hands up. I think the concept of step functions and behind it workflows is the sort of one of the new things that people are starting to really understand. And I know we talk about step functions composed of different states, and you can connect to all AWS services, and that sounds all cool. But the actual idea of doing workflows as a managed service is a very powerful construct, and I think that's a sort of very sort of future way that the cloud is going to be done, where you're just going to have this sort of cloud native orchestrator that is going to connect to things all over the cloud and your third-party services to do things. So Step Functions is a really great service. And Step Functions has got some cool capabilities. Here you got one way where it's request response, where Step Functions goes through a workflow. So if you can think of each thing, it's called a state, but it's like a step. Do this, then do that, then do that, then do this. And the request response basically goes, oh, I'm going to connect to another service, and I'm going to wait for the response from that. So maybe you're going to connect to a Lambda function. Lambda function is going to then run some code and send the response back. But it could be something else. It could be DynamoDB. For example, I'm going to query a database. That's the same thing. Query the database, wait for the response. Another example, I'm going to use SageMaker, for example. SageMaker ML service. I want to do something ML in this ML world. Do that to SageMaker. It's going to then come back with a response. Slightly differently, but in a sort of similar vein, is the sort of run a job, and these for the sort of long-lasting transactions. So, for example, so Step Functions isn't going to wait for the response; it's actually just going to pause until the second thing happens. So maybe you're going to do a build with code build, or you're going to run an ECS task or a Kubernetes pod, or these kind of things. And the cool thing is, Step Functions is built natively into AWS that you don't then have to poll for that blue job or other kind of thing to finish. That's just automatically going to tell Step Functions, finish my job, carry on with the workflow. But the response actually isn't going to go back to the workflow. It's just the notification to say whatever you've asked to run is going to finish. And then another really cool thing for Step Functions is you've got this wait for callback. And it's called a callback pattern or wait for task token, but it basically means the Step Functions will pause until you tell it to resume. Now, this can be a number of things. This could be because you're calling an on-premises service or something in another data center or a cloud or that kind of thing, and there isn't a direct integration. Or it can be you have a human in the loop. So a human needs to sign off on a loan application, or a parcel needs to be loaned onto a truck, and someone's going to then scan a barcode, and that's going to tell Step Functions, well, the workflow can continue. So very powerful integrations that you can use for Step Functions. It connects to all AWS services. So Step Functions has this concept of using an SDK call. So anything in the AWS SDK, and I don't know, it's like 11, 12, probably 13,000 different SDK calls, which is all built directly into Step Functions. You don't have to use a Lambda function for many kind of things. And obviously you can use EventBridge, you can use step functions together. There have been talks earlier today about this concept of orchestration and choreography. So choreography is you've got different microservices that need to talk to each other, and it's sort of this, if you think of a dance, all the dancers are working separately, but they are all choreographed together to create a dance that's all cohesive. While orchestration is very much tight within a workflow where you've got very strict ordering things and retry logic and all that kind of thing that happens. And obviously many applications are going to use both. So how does then serverless compute fit into this picture? Well, great that step functions has these SDK integrations, and great that you can do a whole bunch of things, but you often need to run some compute to do something which is going to be your custom business logic, the thing that makes your business cool. And so we've got sort of three services that you can think about it, and it's sort of on a vertical scale of what you need to manage, and then an opinionated scale from left to right, less and more opinionated. And of course, Amazon EC2, you need to manage a lot more, but it's not opinionated. Thousands of different instance types, you can do whatever you need to do. Through ECS, which is a container orchestrator, which we're going to go into depth, and Lambda above that, which you've got far less to manage, but you do need to do, it's a bit more opinionated on what you can run. So let's have a look at Lambda. Anybody using Lambda? Excellent, excellent. So you may understand this as well, but for some people who don't, Lambda is event-driven. It is literally one of the main event-driven architectures in AWS. An event source is going to do something. So it's a database record's going to change. A request to an HTTP endpoint is going to be an event as well. A change in a resource state, this is going to kick off a Lambda function in any kind of language, which is then going to have something in its code to do something to another service. And there are three different types of invocation models. Asynchronous, behind an API call, you can imagine that. Call the API behind maybe API gateway or function URLs, get the response and come back to the caller. You've got asynchronous, where you just hand the request off to Lambda. Lambda's got a queue and it just handles things asynchronously. That's perfect. And then a very sort of powerful event source mapping where Lambda has a polar service built into it, it's actually free to use. So if you're using things like Kafka or Kinesis or SQS, Lambda can just pull things off that message queue and do the processing from it. So I'm just going to quickly, because I want to show you some Lambda scaling. We may as well do live demos on this, because why not? So all I'm going to do is I have a Lambda function that I am going to run, and I'll explain what is actually happening over here. So I have a Lambda function that, not very exciting, it's literally going to say hello world, and it is going to sleep for 10 seconds. But that's maybe not the most exciting Lambda function. But let's talk about how that can scale. I haven't set up any clusters, haven't set up any pods, haven't done anything like that. I've just got a Lambda function that's running and I want to do something with it. So Lambda functions can scale pretty impressively. And they can scale up to 1,000 executions. So each time a Lambda function runs in parallel, it's this parallelization kind of thing, you can run 1,000 at the same time every 10 seconds. So in 10 seconds, in 20 seconds time, Lambda can scale up to 20,000, 30,000. So this is literally the fastest way you can get a huge amount of compute in the cloud without having to pre-plan any of your scaling in advance. And when I spoke about that sort of consumption pattern in the beginning, this is a great way if you've got varying traffic patterns. It's just going to scale automatically. You don't need to set anything else up. Now, we did have a previous scaling thing which worked for the first sort of 9 years, I think, of Lambda, where instead of that 1,000 every 10 seconds, it was initial 3,000 burst and then sort of 500 every minute, the sort of staggered approach that was going up. And that meant if you needed to have 10,000 Lambda functions working in parallel, that would take 12 minutes to get up to that. Now, it's not the end of the world, because 10,000 sustained requests is a pretty big web application, and that's from a standing start when you're doing nothing. Obviously, if it's a slow ramp up, this would be absolutely fine. But the Lambda team were like, no. We can do better than this. Let's improve it. So in reInvent last year, we announced this 1,000 invocations every 10 seconds, and this is also now per function. Previously, it was for all the functions shared within your account. So that means from 12 minutes, we are literally down to 90 seconds to get up to that sustained request. So, 10,000 concurrent hits on your website or something like that, this just handles it natively. Don't have to do anything to see that running. So in the background, I've actually been running that scaling. So I had this Lambda function. I'm using this little utility called Hey. It's called Hey, because it's actually really hard to stress test a Lambda function in this way. To create 10,000 requests from a single machine, I don't have a botnet that I'm running all over the world to be able to hit my Lambda function, but this utility called Hey is really cool. I'm not sure how much you can see on the screen, but it doesn't really matter. I'm just saying, please run 10,000 requests to an API gateway endpoint because I have a Lambda function that is here connected to an API gateway. What is more importantly is, here we go. So this is, I've got a graph, and I've got a graph of my concurrency, which is the blue line, and the throttles, which is the orange line. So here you can see immediately, as soon as I start with 10,000 immediate requests, what's going to happen? 1,000 requests are going to be allowed in the first 10 seconds, and then 9,000 are going to be denied, going, hang on, I'm not ready yet, just wait a little bit. But obviously 10 seconds later, Lambda's going to say, okay, now I can accept 2,000, 8,000 are going to be throttled. So you can see this sort of very clear ramp up for the concurrent executions, and it doesn't, okay, the graph hasn't quite behaved itself when it starts at 3,000, but you can see here I'm at 10,000, what is that, 10,900, I don't know where it came above more than 10,000, maybe I ran this beforehand, but sometimes it's very annoying, sometimes it goes 10,001, and you're like, where did the other one come from? Please do my demo nicely. But you can see basically here, in a very short amount of time, probably over there, that's 32 up to 34, so maybe 2 minutes. So, to 1.5 in 2 minutes, without doing any configuration, without doing anything, I've basically scaled up a Lambda function to be able to handle 10,000 sustained requests, and this is just going to run. So that's a really powerful way to that I can get a lot of compute capacity in the cloud. But Lambda, as I mentioned, had this event source mapping where you can pull from all these various sources, filter and batch them up, and send in to your target Lambda function. Sorry, something sounds really weird. I've got a bit of an echo. But also, the Lambda team said, well, those are synchronous requests I was hitting an API, but we can do much better for these event source mappings. So previously, SQS also had a sort of gradual scale up that it was doing, and we were like, you know what, we can do this much better. So at reInvent again last year, we also dramatically improved how quickly SQS scales up, and also how that we actually delay the scale down. So if you're using SQS, you can get Lambda functions to spin up a much quicker. And that sounds all great, but sometimes you also want to control that. You don't want unlimited Lambda functions running because maybe you've got a downstream service. So what you can do is you can actually also, on the event source mapping, configure how that works. And so you don't, you say from SQS, only poll at this rate, and then I don't unnecessarily send invokes to a Lambda function, which is going to throttle. So it's just a configuration setting that you can control how many Lambda functions run off an SQS queue, because it's awesome that we can scale this far, but I don't always want that. Sometimes I've got something downstream that doesn't work. And we've done the same thing for Kafka. So you can see, big event processing, you can imagine Kafka or Kinesis as well. And, really huge throughput of Lambda processing. And you can see that sort of near vertical line that comes up, the orange line, show how quickly the pollers get up and running. What's interesting is right at the end, you can see how sort of the vertical drop, that the pollers will stay up and running as long as possible to be able to drain that this Kafka service at the moment and do your processing as quick as possible. So basically the story is behind the scenes, Lambda is trying to do as much as possible to speed things up and improve the throughput. So that is the sort of serverless functions compute part of it. All about scale that matches your workload, fast scale up, connecting to a whole bunch of different services with far less work to do. But there's obviously another way that you can run your code, and these are in containers. Anybody using containers? People using containers. Anybody using ECS? Yes. Anybody using Fargate? We have people. Cool, excellent. So I'll explain how this works, and then we'll go into some of the differences. So Amazon ECS is a container orchestrator. It is actually, in a way, serverless because there's nothing, you don't have to install a ECS, you don't have to do anything, it's just a service that runs in the cloud, and it's a fully managed control plane. It doesn't cost you anything, you pay for the compute resources, but the actual container orchestrator is free to use. And yeah, no cluster versions, no data store, none of the stuff that you need to do to keep this container orchestrator up and running. I know the people who are using Kubernetes, and there's really good use cases for that as well. But if you think about this, Kubernetes does need a lot of infrastructure for Kubernetes to run, for good reason, that's what it needs, but ECS doesn't need that, it's just a sort of serverless control plane. And then Fargate is where the work happens. So Fargate is the data plane, this is where your containers actually run. But again, we manage the EC2 instances that run underneath it. You don't have any AMIs that you need to do, and we'll handle the provision, the scaling, and the management of it. And and you just pay for the compute resources that you provision. So, just looking at ECS, The cool thing about ECS, Lambda has got great integrations from this event-driven model. ECS does have integrations, but it's not an event-driven model, partly, you'll see a little bit later, but ECS does have integrations with all the code suite, and then also, secrets manager, native integrations, and key management store for making sure you've got your secure credentials and things. And then, of course, the whole world of open source container orchestration stuff, Prometheus, Grafana for logs and metrics and all these kind of things. And sort of anything you can run in a container, you can connect out to all these different services. So, a broad picture of services that you can also use with ECS. ECS does have some core constructs, so it has a task, and this is just one or more containers that you define, and you can then configure what compute capacity that's got, some of the networking stuff, some IAM and things in configuration. And then a service is basically just one or more identical tasks. So you can imagine if you need to scale something out, or you've got a front-end website, you need to run this across multiple AZs. Lambda is multi-AZ, doesn't need to worry about AZs, that just handles it automatically. But for ECS, this is something you explicitly work on. But a service is multiple tasks, and they sort of work in unison. And ECS has got health checks to make sure that these services are up and running. And then a cluster is sort of a logical grouping of services and tasks, and handles the capacity in a region. And underneath that, you can use standard EC2 or EC2 Spot. And then on the serverless side, you can use Fargate and Fargate Spot as serverless containers, which I'll explain shortly. So you may have picked up two different words. ECS is this concept of tasks and services. So tasks are on-demand workloads. The ECS task scheduler runs them, and this is something that runs as a batch or runs once, and it uses the run task API. So this is event-driven. So an event will kick off a ECS task. It's going to run. It's going to do what it needs to do, and then the task is going to finish. While services is a long-running app, so I mentioned a front-end website, for example, spread across 3 availability zones. Well, that is going to be a long-running service. It has the service scheduler, which is going to manage them coming up and down. It's got some in the health management in it, and it's going to sort that out. I talked about the availability zones. Yeah, you can figure out where stuff is going to go on the availability zone. A task definition is just this whole bunch of JSON over here, and you set memory, you set CPU, whether it's going to be Fargate or ECS underneath the hood to make that actually work. So let's talk a little bit about Fargate, because this is the compute engine for containers, and this is very much serverless. You don't need to worry about things like that. Each task is going to be run in a dynamically provisioned instance. So although there are servers behind the scenes, Fargate is running on actual EC2 instances. You've got no access to them. You can't see them. You don't need to manage them. You can't even SSH into them. But this is a cool way to be able to use a container construct without having to manage EC2 instances behind them, which is really cool. You then configure the tasks based on the CPU and the RAM, and then that obviously configuration is applicable to all the tasks that sit, all the containers that sit within the task. Now, Lambda handles patching for you and does a whole bunch of stuff for you. Fargate, there's a little bit more that you need to do. But AWS is still going to manage the underlying hosts and all of the infrastructure. If thing fails, it's going to replace that. But anything your code related and your runtime and anything that sits within the container, that's your responsibility to look after in terms of patching. In terms of load balancing and ingress, yet again, it's a bit more of a do-it-yourself. You manage the ingress and the load balancing with some sort of load balancer in front of it. And then AWS is again going to manage the instances behind that. If they fail, it's going to replace that. All that EC2 stuff behind the scenes, that's AWS's responsibility. And then in terms of scaling, it's not the same auto-scaling that Lambda happens where it just went up to those 10,000 requests, but you've got a lot of control and sort of really interesting control that you can do. And you can use AWS auto-scaling, which is a service from AWS, using CloudWatch metrics to say when my task throughput reaches this number, add a new task. When it goes below, remove a task and do all that kind of thing. So you can use metrics from anything, you can use metrics from third-party services and all these kind of things, but you use basically AWS auto-scaling to be specific about when you want to scale up and when you want to scale down. So it's not automatic, but you don't necessarily want it to be automatic because you want to handle how you're connecting, how many tasks you've got across which availability zones. Again, underneath the hood, AWS is looking after all the compute capacity and infrastructure. So we're here at EDA Day, let's talk about the sort of EDA patterns using containers. And so when I mentioned earlier, a task per event. So this is a common thing. You want to run a container when something happens, event-driven architectures. So in this example, you load something into an S3 bucket. That is going to automatically kick off an event bridge rule. And that event bridge rule, which has got an integration with Fargate, says, please can you, or ECS and Fargate, please can you spin up a task and do something to to download the image and do some work with that. So it's a one-off task that is going to run when the task is finished, that the service is going to then shut down. Now, you do need, it doesn't have a native integration like with Lambda, so you do need something like event bridge or step functions to kick off the task, because something needs to invoke the task, but as you know by now, step functions and event bridge, they're really easy to create these orchestrations to do that as well. And so the use case would be, less frequent events. You don't want a service that's up and running and polling all the time or doing something all the time. Something less frequency, you can just use this to run. And obviously, Lambda functions, how long can a Lambda function run for? Anybody know? 15 minutes. There we go. We've got people still awake later on in the afternoon. Excellent. So if you do need something that runs for longer than 15 minutes, you've got some big processing or some kind of thing, you can't break it up, then this is really a great use case because you can have a long-running task. So on the services, I did talk about a web workload. That's a very obvious way. But there's also an event processing workload. So say you have something on SQS, for example. Now, I talked about SQS and Lambda for scaling. Well, there's a different approach. You can also use a container as well. If you've got very high throughput, you've got a lot of data coming into SQS, you prefer to have that sort of steady state consumers, this is a great way to do it. So ECS is going to handle the deployments, the auto scaling and all that kind of thing. And yeah, you got a lot of events, very high frequency. This is a way that you can also use containers for these kind of workloads, which may have some cost implications, which may be better for you than running on Lambda. And you don't need to configure this all manually. You can use the CDK. Anybody using the CDK? Cloud Development Kit. So this is a way to generate cloud formation, and we've got these sort of L3 constructs. So basically all that configuration stuff that you need for ECS is wrapped up in some simple to use constructs which you put into your code, and then you can set up all these kind of things and set up distribute between the on-demand and spot and set up all the configuration. It's just an easy way to do it in code, so you can use infrastructure as code with your container workloads as well. Another use case is file processing. So I spoke about this beforehand. So you do have something, this is the event-driven architecture kind of thing, where you have a video or a file or something loads up to S3, which then kicks off an event bridge rule, which then maybe uses step functions. And in this case, well, it's actually going to choose between Lambda and Fargate to do something and put something in an S3 bucket. So let's see how that actually works. Now, I have a ECS task over here. I don't have any task. Nothing running. So how much this is costing me? Because ECS costs me, it's only when the tasks are running that it's going to cost me some money. So I have defined an ECS task, which is a task definition. It's got a certain amount of CPU, it's got a certain amount of RAM, it's based on a Fargate instance, all that kind of configuration, but it's not doing anything, and so I'm not paying for anything at the moment. So what I'm going to do is I am going to kick off an S3 copy, which is going to basically just copy a file from one S3 bucket to another S3 bucket, which is going to kick off an event bridge rule, which is going to go to step functions and is then going to do something. So if we actually look at my step function state machine, we will see I have a running execution over here. You can see, basically, I've got a use case here is I have a file, and I want to use Lambda for the small images, and I want to use Fargate for the big images because it's going to take more than 15 minutes to run. Now, maybe this could be an image, and it could be a video file, anything. The point is to show event bridge kicked off a step functions workflow, and I'm picking between Lambda, and so this is running the ECS task. So if I now go back to ECS, that has provisioned a task. I now have a running ECS task. It's entirely it's entirely event-driven, and you can see here I have 4 CPUs, 30 gig of RAM. Anything interesting? It is running with Fargate under the hood, and that's just running. And you can see the container name is step task because that was my task definition. So by simply copying a file up to S3, wiring it into a little bit of event bridge, wiring event bridge to step functions, which isn't a hard thing as well. I now have a task division, which is a task which is using 30 gig of memory, which is more than a Lambda function can run, and this task can run for as long as it is, and it's entirely event-driven. I didn't pay anything, and as soon as this runs, I'm just running the task, and then the task is going to shut down. So people often don't think, oh, you can do event-driven architectures with containers. Surely containers need to be up and running all the time, and you can sort of scale them. No, this is a really useful way that you can do containers with ECS and Fargate. There was a talk earlier from Natasha Wright, and she was talking about a similar concept with Kubernetes. So if you are using Kubernetes, there are two tools, one's called CADA and one's called Carpenter, again, where you can have event-driven Kubernetes. So that's all working. I'm not going to wait for the 20 minutes for the Fargate task to run, because that'll be the most boring, boring use of our time. So the question you may be thinking is, which serverless compute option is actually right for my application? So for your application, who's going to use Lambda? Some people. Who's going to use ECS? The thing is, you have no idea what your application is. You're thinking in your head what you're going to use, and that's obviously not common in this room. So we need to work out some decision trees and reasons why you may use one compute service over the other. And there are some architectural decisions. So when I spoke about Lambda in the beginning, what is the really cool thing about Lambda is it works with all these managed triggers and a runtime. You know, the integration with API Gateway is just there. The event source mapping for SQS or Kinesis or Kafka is just there. DynamoDB Streams is just there. It's got all these managed triggers. It's got managed runtimes. So you're doing Node, Python, Java, Go, .NET. I've probably forgotten some others, but basically, AWS is going to manage those runtimes for you, and he's going to upgrade them and patch them so you don't have to do anything. So that is a huge benefit, that you don't have to manage things in your container yourself. Lambda is just going to upgrade that on your behalf. Slight nuance for the clever people in here who say, oh, but Lambda functions can run as a container image, which is entirely true. It's a sort of halfway house between both. If you do configure your Lambda function as a container image, you then do take on the responsibility of patching, because a container image is a immutable artifact. That's just the way containers work. But if you're using a zip archive, you've got all these runtimes that are going to automatically upgrade. Behind the scenes, that is an amazing thing to happen. I don't know if anyone remembers a few years ago where the Log4j came out. And lots of Java programmers spent a horrible, horrible Christmas fixing all their Java code. As Log4j was announced, anyone who was using Lambda were like, yeah, we're done. Lambda just upgraded Log4j, and that problem went away. So super, super benefit. And of course, that scaling, as I mentioned, the scaling up and down, all managed by AWS, you don't have to do that as well. But sometimes, container for an architectural consideration is when you do have custom code. You've got services that don't natively interact with Lambda, or you've got services in other kind of places where you've got a connector kind of things, and it doesn't make sense to use a native integration with Lambda because it doesn't exist. And you've got some custom code, maybe something that's on premises or somewhere else, or you want to have the same code that runs in various different places, and you don't really want to fit into Lambda's programming model, then you can use containers, which is a great thing. But it does need a little bit of management and orchestration, but we're continually working on that to try and make it a little bit easier. Then, of course, there are resource considerations. Lambda functions can run from 128 meg to up to 10 gig. You saw my demo over there. It was that was a 30 gig Fargate task. So 0.5. Fargate, you can separate CPU and memory, and all the way up to 120 gig of RAM with 120 gig in size. So yeah, different resource considerations. On the networking side, when you add more memory to a Lambda function, that's the only performance configuration you get. You get proportionally more CPU, and you get proportionally more network. Cool, all simple, but maybe that's not quite what you want. Maybe you do want different network modes, or you do want different CPU things that you need to choose. If you want more control, then ECS on Fargate is the one you're going to do. Lambda functions, the clever people knew it was only 15 minutes, unlimited with Fargate, so if you need long-running tasks, that's going to work as well. Lambda function, every time it runs, it's one single event that's going to go through. Super powerful. It's a great way to build event-driven architectures, but sometimes that just doesn't work. Particularly if you're running a high throughput SQS polar, as we saw before, or a high throughput website, to have a single invocation for every time somebody hits your website, maybe that's going to be cross prohibitive for you, and maybe you're running some multi-processing within Python or Node or this kind of thing, and you want to take advantage of multi-concurrency, then ECS Fargate is your friend, because it's going to be able to support that, because ultimately it's just behind a load balancer. The requests are going to come in across your containers, and very high throughput. So there are some considerations for paying for what you provision. So Fargate, when you provision something and that task is running, if you use it or you don't use it, you're going to pay for that. So you can see there's an initialization phase, and then all the requests come in, but you're basically going to pay for that chunk. If you've got one request coming in or a million requests coming in, you're going to pay for that chunk. And so that obviously means, if you've got a high traffic and your code is efficient, this is definitely the lowest per request cost. So that's something you're going to do. But Lambda is different because you pay for what you use. So a Lambda function is going to start, do a single invocation. When there's no invocation running, Lambda basically goes to sleep. Next invocation comes along, it wakes up very quickly, does its invocation, and goes to sleep. And so when there are gaps between work to do, or it's very variable workload, and you don't quite know how long you want to, how many tasks you need to run, this is very efficient and can save you money and can be really fast. So, and it scales down to 0. There's no charge when between those gaps when it's not running. Super powerful architectural pattern. So, ideas on scaling, ideas on selecting serverless containers. So, serverless containers, when you want low-ish startup latency, it's not as quick as Lambda, but it's low-ish. Nothing like EC2 when you need to when you need to put up an instance. More than 15 minutes, high traffic use case, and when you need data persistence. So Lambda, runs a little function code and it's going to disappear. Serverless containers with ECS and Fargate, you can attach an EBS volume to it, so you've got some persistence that you can then share and do that kind of thing. So, also, when you need then control of your compute environment, you particularly want to select CPU and memory, or particular instance type, instance kind of things that's available with Fargate, that's available for you as well. And of course, tooling consistency. Lambda is a different kind of model, but if you are already using container tooling that works in a whole container orchestration way, and the packaging part Lambda can do, but there are a lot of different, observability tools and a whole bunch of other kind of tools that don't work with Lambda but work in your container way, then this is a great way you can have consistent tooling, whether your containers are running on AWS or other kind of places. This could be helpful for you as well. Then when you want serverless functions, you want that immediate startup time. You need like that 10,000 requests and didn't do any config, didn't set up any auto-scaling or anything. Off you go, and it's going to be variable workloads. When you do have the triggers coming in for trigger an action on an event, that's going to be super useful. The varying utilization and when you don't actually know the demand. Also, you want to make fewer decisions. You don't want to have to decide what your auto-scaling policy is or your scale up or scale down and just get Lambda to figure it out for you. That's really good. Obviously, when I mentioned in the beginning that faster prototype to production, this is a great way to do that as well. When you are comfortable handing off the operational complexity, the resilience, the scaling up, the patching, all that kind of stuff to AWS. And so there's some people sort of get this slide, and I never know where to put it in, but sometimes it helps people that if you've got a lot of requests with stable and predictable workloads, Fargate is your friend. If you've got variable workloads and they're sort of intermittent and it's has spiky or off hours, then Lambda's going to be your friend. That's going to be the way to do it. But some of you are thinking like, oh, a lot of slides. I just want it a bit simpler. So the takeaway is ECS Fargate is your friend, long-running, stable, high-volume, high-resource event sources. Get the best bang for your buck for ECS Fargate. And then for most other event sources, try Lambda. Now, I would often suggest that you maybe try Lambda first to see if that works for you. And then as soon as you understand your architecture, you can then you can do things as well. But also, as I mentioned, there's no reason that this is an either-or decision. You can 100% use both. And so in this example, which I showed in the demo, which we didn't go through entirely, but you've got an example. I've got an image file and I've got a video file. Now, an image gets both uploaded to S3, triggers off the event bridge rule, and then step functions, what did that do? That had a decision tree. And the step functions was as silly as going, I've worked out something, okay, this is checking the image size, but it could be, is this an image or is this a movie? And so, say on the image side, is it bigger than, I don't know, pick a number, 1 gig or something. So 1 gig would be much more efficient to run on Fargate, so why don't we spin up a Fargate task to do that? Anything smaller, let's use Lambda. Maybe I should update this to talk about, images would go to Lambda and movie files would go to Fargate, because if it's going to take more than 15 minutes to run or any of the considerations that you can do that. But here you're building it into the same application. You've got choreography because you've got orchestration working, because you've got something coming from event bridge going to step functions. There's a no-code if-then statement that's going either way. There's no code to manage. Run either one of those things, and you can see what then happens is once those are complete, it's just going to send a message to EventBridge, and then maybe you've got another third-party service or your own service says, whatever conversion process, whatever task was happening, that is finished, and the rest of your event-driven architectures can carry on happily as well. So the point is, it's not a Lambda or ECS Fargate. They got great use cases separately, but also you can use them very much in the same application as well. But, that's not the end of the story. That's just the story today. We are always going to be working on the fundamentals. We're going to try and improve the developer experience as much as possible. We're always going to be adding more guardrails, more controls, more connecting to other services, and, better integrations with all that other kind of things. So watch the space. reInvent is coming around the corner. I'm sure the Lambda team and I'm sure the ECS team, well, I say I'm sure, I know they are working on some cool kind of things, and all the other serverless services I spoke about as well, and maybe there are even going to be some new ones. AWS is, serverless is very much in the forefront of how AWS does things, and so the road ahead is bright. There's lots of cool things coming out as well. So thank you very much. I appreciate your time today. Go build and enjoy building serverless compute applications. Thank you very much.